Oh man, sometimes I hate using this program. So I just want to copy the frickin' arrow. So this is kind of, if this was the flow of the water, and then we would overlay on top of that our splashes, right? We could have things would look something like that. And we could have this kind of follow around. So we need, and how would the flow field work? Like, how would the hell would we even make that flow field, right? Like this would be a, flow fields are flow fields. They are things. That's not a problem. In terms of a concept to program and work with, the issue is how would we make a scene like this, and how would we actually know, like, okay, well, the water should flow out from here and should exit from there. How would we do that? Would we have like we could mark an area as like water comes in here, and then we could mark an area as like water leaves from here, and then we could just compute it, and basically it would, it'd say like, okay, water comes out, so it would be like, okay, arrows should kind of circulate and stuff like that. We could program it, and how you would make a water area is by putting in like water input emitters. So it'd be like water is here, water enters here, water leaves here, and it would just kind of magically, we'd have like a little compute button or something, and it'd be like boom, and it would compute a flow field for the water for us. But to do that, we would need to know where the shore is, and stuff like these sorts of rocks that are in the water, it would need to know where they are as well. So how in the hell would we do all that? I mean, it'd be really cool. And then to make a river or something like that, we'd be doing the same thing. You just slap down a thing and an emitter for water at one end and an exit on the other side, and then just click the generate button and it would generate the flow field. All right, we could have a flow field which we pre-generate, which has the direction for water motion. And to create this, you'd define areas where water enters / leaves. And I'm not even sure how the hell we would do this. Like in the actual editor. Like we could try placing objects and crap like that, and then like the water could look for them in the world, kind of like how planar reflections and water work together. Where we could just, you could slap down like a volume or something like that. That's probably the easiest thing to do, is to have something kind of like, I'd have to look at the point lights or stuff like that. Yeah, okay. These would be objects in the world which are volumes which have properties. The water object would look for these objects when generating and apply them to itself. And the same with fogs, yeah. Alright, so the question is how... So if we've got this flow field situation going on here, with this waterfall and all this other crap, we can generate that. I should actually throw... throw a rock out in the middle. I mean, is it basically that we need to make a height map? And how in the hell would we make a height map for this object? Because if we want to figure out where the shore is, so if we took, I think, what is the term in medical? I just want to look this up real quick. Alright, so I guess it's called a traverse section. Officially. We basically want to take the traverse section of the level, and how would we do that? Basically what we want to do is we want to get the height at every point based on this. So what we could do is basically we do a raycast. Like if we have the resolution of this texture, like it's 512 by 512 or something like that, right? We could raycast down into the level, right? It looks like Twitch's dashboard is not working anymore. But yeah, what a surprise. But basically what we'd be doing is we do a raycast down from, infinite height above us, and, well, no, we want to do raycasts at our height going down, and if we start inside of an object, then we're good, because we'll just say, well, there's an object here, so this is height equal to our stuff, and we basically just render a giant grayscale texture. I mean, or we could render an actual, like, height texture. Well, I have no idea if all the dashboard stuff's working. There it goes. It'll come back online here. So we just did a whole bunch of sweeps. We could do, 512 by 512 sweeps to create a height map. Have a texture resolution for each pixel in our texture, do a raycast against the world, any collision type, and we want to make sure that we catch collisions for things we're inside. We want to ignore certain objects. Like in our level right here, like for a height map, for sure or something, we don't want to consider this. We might collide with this or something. We don't want to consider it actual water. We don't want to consider actual shore. And like if we had a mushroom or something, anything above this, well, anything above the plane here doesn't matter. It would be things that stick into the plane. That's not a big deal. I think we'd be okay with that. Yeah, but we do want to ignore certain objects, and we want to then record the height in the texture as a float. So we just make a height map basically, and then we pass that texture. We store that texture. And how do we store this? Is there a place in the level to store a texture? So if we had those things together, if we had the height map, we know where the shore is. And if we knew where the shore is, we can do stuff, like we can reference this. We could actually make our flow field based off of not only the shore, because we know where it is. We would not want anything moving in here for the flow field. So if there was an object on the water that was moving, we don't do anything with that. So what other techniques might we use to Because I've actually never made a water lake area thing ever before. So I'm just making crap up here. I'm like, well, what the hell would work for me? You know, what makes sense? So this would allow us, we'd know what direction we're going in. We'd know, you know, if we had two textures, one of which is the flow field and one of which is the height map inside of our material, we'd basically be like, oh, the water speed is high here and it's near shore or something. Maybe we should do something about that, you know? All right, so how would we have ripples? I think we have a ripple texture. Like we need a, yeah, okay, so textures into our material. We have the height map for detecting shorelines, etc. We have the flow field, which is the velocity of the water at a certain point. So like the RGB values are velocities. We're going to want the ripple field. So that'll be like ripples that are coming off. And how in the hell do we do that? Are we rendering to this ripple texture every frame? I mean, we could. That wouldn't be the worst thing in the world. Let's see, are there any other strategies for ripples? I mean, we could just have an array of ripple effects that are actually passed into our material, and we could calculate in the pixel shader where ripples are. But I mean, every single pixel would then have to calculate ripples as opposed to just looking up the answer. Like, if we had 32 different centers of splashing, we would have to calculate for every single pixel what was, you know, you'd have to calculate them all together for the specific place where we were, and which wouldn't be the worst thing in the world, but it would be a lot of math, and it would be a little bit clunky, as I don't think we have dynamic arrays or any of that, and we don't have arrays and for loops inside of materials. Or do we? Yeah, we don't have for loops. Alright, so we're not going to be looping over any arrays inside of this material, so we could always have a set number of like channels, and you basically just copy paste them, and you're like ripple 1, 2, 3, 4, 5, and 6. Kind of like how old DirectX lighting worked, where you could have like up to 4 different lights in your scene or something like that at the same time. And you just set like light 1 value, light 2 value, and those got all passed into whatever DirectX could use. This was before vertex shaders. That was, I think, called the fixed function pipeline stuff back in the day. And the height map is generated statically. The flow field is generated statically. And the ripple field is generated dynamically. The question would be, the height map generated statically, I understand why. That's a lot of raycasts. That is all garbage. Should we be able to update the flow field? Would be a question. So why would we update a flow field? Well, let's say we have a waterfall and we turn it on or off. It would change the flow field. I don't know. I mean, we could have a dynamic flow field sort of thing where we could have temporary effects that change, the local water or something like that. Like you drop a rock in there and the ripple field would have the ripples, and then we could have a dynamic flow field texture as well, which just like says water should move away from this location. They just fade it out. And like, it wouldn't take any, it would be a real stupid flow field thing. So you could have like an overall flow field, and then you could have like, just stupid flow field. Alright, so we could have a dynamic flow field texture if we really need it, and this would be a quote-unquote dumb dynamic texture. Alright, so let's see, what would be... So I think that would be enough information to actually put together a decent water effect. Like, we'd have ripples along the shore, in terms of like we could have shore effects that are passive. Like in this piece of concept art, we've got, what we would have is this sort of little effect right here would be a combination of detecting the shore along with the velocity of the water with some like panning effects and math. We could totally do that. These little drops here are just some noise added to a ripple that comes out. This whole motion of water in one direction is just, we have like water comes in here and water exits out there on this big water rectangle, which happens. I don't think we're going to have actual waves, so I don't think that we need anything other. We don't need any vertex manipulation of our water. I don't think we're going to do that, because we're not making an ocean with, big swells. And if we move our vertices around, we're going to get all sorts of screwed up planar reflection stuff, and reflections are super important in this game. So let's just throw limitations. Limitations. Cannot use vertex deformation. Basically, assume we're a flat plane with 4 corners. All math in world space. And yeah, so we get our motion, and then this stuff over here would be a waterfall ripple emitter. So let's think about some limitations of this. So if we have textures which deal with this piece of water, the resolution of those textures is going to directly affect the quality of these things. So if we have like a winding river, right? Like we had a river, like this one, which is actually going into the background. So it's this big, long rectangle, which is long and skinny. And if we had a texture which goes over this thing, textures basically need to be powers of 2 in order to really nicely work properly. So we'd be losing a lot of information if, we'd be losing a lot of quote-unquote potential information if our bodies of water are not square. So how the hell can we deal with that? Like, we've only got textures. That's all we've got here. And we could use the texture as a 2D array. And we could define, like, if we use the texture as a 2D array, as opposed to a square, right? Your pixel is not going to be your UV coordinate. Your pixel into this array is going to be like your UV coordinate, but then you'll back convert that to like a different thing. It'll be like, oh, well, if, this is a 512 by 512 texture and my U and V are these coordinates, I know my X and Y, and that would normally be the lookup, but the width of this texture is, the width of the thing in the world is actually, 128. So what I should be doing is taking, 128 and then sampling this other pixel over here. So we could do, I guess, optimizations. We may be able to use non-square textures by using different indexes. To use, we may be able to use all our texture information by using different index lookups into the texture based on a defined width/height. Let's see, limitations. The size of the textures will directly impact performance and detail for the scene. And this means that large bodies of water may look bad if we don't use large textures. So the question would be, would it be possible to use multiple textures for this sort of stuff? Like, would we need that level of information? And would that even matter? And we could have LODs or something. But I think if we just kept it simple, like if we had a big lake or something, and want to know where the shore was, I think we'd be hard-pressed to make something that looks like complete trash. Alright, some other limitations. I think two bodies of water would not be able to interact with each other. So if you had like a river and a lake attached to that river or something, they'd have to be the same body of water, which means they would need to be on the same plane because this is a flat plane. So if they did interact with each other, basically you need to throw a waterfall in the way. Like, that's the only way we'd be able to do it. Which is another thing that we might want to think about If we have a waterfall and we want to like change how the water works as it gets close to a waterfall, what would we do? Like we could have the flow field. It's going to know like, oh, this is someplace that's supposed to be sucking water towards it, so we should increase our velocity. So the inside of the material, we could say, well, the velocity of this pixel is very high, so if it reaches a certain threshold, it's like we're whitewater now, as opposed to calm, glassy water, and we could change our reflection and a roughness for our material in there as well. So as this thing approaches a waterfall, it would get, we could do something about that. Yeah, planar reflections need to follow along with this as well. I mean, I'm just going to be sitting here for hours just thinking about this, right? Just because I don't know what the hell I need to build, so I need to like get my brain engaged into it to think about what we need to do. Alright, well let's list out some interactions that we'll need with water. We need to be able to create ripples dynamically. This would be a oh, that's another interesting. A rock falls into the water. The other question would be like, what if we have like a leaf land on the surface of the water? We could actually sample the flow field where the leaf is, and then have the leaf move along the surface of the water. Like, this would be look up into flow field based on position. So we could definitely have that sort of thing happen, and we know the height map of the area and all that stuff, so we could definitely have something move along the edges and stay away from shore or wherever the hell we needed to. Bitey is going to need to be able to run on the surface of water and fall into the water, but that's just a ripple effect and stuff like that. He's going to be moving along it. So the question is, if there's an object in the water, like just in the damn water, how do we model that? Right? Like, so like, if we tried to, if something is standing in the water, this is like old school Zelda, as you can see, we've got like these ripples that are right around it and stuff like that. So we need like, do we need something else in here? Like if we had the ripple map there, would there be something that it would allow us to do? I mean, we could have another map that we put on there, which is like a dynamic object map or something, where we could basically have, a collider around Bitey or whatever, and we'd have an object that intersects with the water, detect it, and add itself to the water, and say like, hey, there's an object here. And what the hell would even happen? I mean, we basically want to draw like a sphere around that with a certain influence. Because I'm trying to think, like, if Bitey, you know, I don't want to put limitations on the water system to start with. Like, let's say we have this piece of concept art here, but instead of it being nice and empty, like, Bitey's actually standing in the water. What is supposed to happen? Like, we can have a ripple effect come off of him, you know, whenever, which, you know, based on the flow field, we would have, you know, like, stuff come off of him. But we'd want, like, you know, some sort of effect around him, wouldn't we? Or would the ripples be enough? And he's occluding everything else. I mean, it's probably not going to be enough because Bitey is two-dimensional. Right? He's not a 3D object. He has 3D... He's got 3D geometry, but he's a box. So if we threw him in there, he'd obviously be a box. You know, like if you took a board and you shoved it in the water, like it's gonna look, you know, a certain way. Would the dynamic flow field be able to handle this? I mean, I almost want to cut a hole out of the water, which would be rendering the opacity at 0, or just rendering the water you know, at a certain, just like it would just render as a certain color or something like that. So I think we do want like a cookie cutout. So we need like an obstacle texture where we would write things to it and we'd look it up, and if this would be a dynamic texture. And we draw simple shapes to it, and it would be grayscale. So it'd be just like an influence map. And this would be used for objects in water. Making it not look bad. We need like add/remove from list of objects influencing the water. Other interactions would be, we want to create a thing to float. Yeah, we need to be able to create ripples dynamically. We need to be able to create flow dynamically. Should we have like some sort of turbulence map or something else like that where we can just like create some sort of like, hey, here stuff screwed up, or would the ripples and flow field stuff just kind of solve that for us? Like, for instance, you know, you drop a rock into a piece of water and it, boom, you know, water comes back up as the waves come inward. Is that something we deal with here or not? I think not. I think we've got the ripple that's going to come out of the, and then we have other effects that we'll put on there for like splashing. Alright, so let's think, is there anything else that we need to worry about here? So we've got it so we can, if we've got our water, it's coming off, we can walk on the water, we can walk in the water, we can move the water through our scene. We know where the shore is. We know where these rocks are. We can drop a rock in there. We can have a leaf that falls in and then kind of meanders around and falls off. We've got it, so perhaps the resolution of the textures that we're dealing with are, well, they are square textures. We can index into them differently so that we can have different shaped water than just squares. Planar reflections will work. Got all of that. We know the height of the water at a specific location, so we can use that to change any subsurface volume stuff. I don't think there's any other information we really need too much. There's no wind speed or anything else. So the question would be if we had some sort of wind effect come up. Like we could have a global wind speed sort of thing, which we could just be a variable with a direction, and that could change the flow field. So if the wind came up, we could do something with that. Okay, so maybe I should write that down too. So instead of textures, let's say inputs into our material, and let's say height map texture, flow field texture, dynamic flow field texture, ripple field texture, obstacle influence map texture. We're going to want a global wind speed. Okay, so let's think about it. Let's say we have a big storm that happens, and we've got water like this. What's going to happen? We're going to have a whole bunch of rain come down, and we're going to need ripples that happen on the water. So how would we do ripples? Well, we would just have a certain amount of ripples that we put on there with the rain effect, randomly put them onto our surface with a certain number of drops per minute or something. And we'd be able to support all that sort of stuff. It's more CPU, directly scales to the number of drops. And we'd also have some sort of, storminess or some crap that we could throw in there as well on top of it, which would make it look fine. Any other effects? Any other effects that we want to think about? Because we can get these ripples along the shore, that's not a problem. You can see also there's wetness along this area on the rock. You can tell that this area is darker in some of these spots. Is there any sort of interactions that we need? Hell, our flow field will even let us do this. This little chunk right here would actually work. could do rivers, we could do lakes with this, because the lakes are basically, there's no flow. We could do some really interesting effects with flow fields. Okay, make a giant whirlpool. It would work. Hell, if we programmed it properly, whirlpools would just happen. Like, because we got like a velocity for a flow field comes up here, and it's coming along the shore and comes out, we'd actually have a bit of noise and turbulence that would happen as a result of that. So we may naturally have whirlpools if we put little crazy areas. That would be really cool. Well, I think we've got the tools we need then. I think we've got a pretty good plan. So height map, flow field, dynamic flow field, ripple field, obstacle influence map, global wind speed, all that sort of stuff can come together to give us a lot of effects that we will have. Makes it interactable. And all of that. So what are the objects that we're actually going to need to make in order to get water working? We're going to need a water blueprint object. We're going to need some water influence objects, such as objects influence components, things that auto make ripples, etc. So water influence components need to make ripples at runtime. Ripples runtime will need to make make flow at runtime, and make ripples, make flow at static build time. So I think that's kind of the idea, is we'll do stuff like that. We need a robust interface on our water. Like let's say we have a fat sack and he like jumps in the water and he just I would imagine the fat sack would float. Those guys are little sacks of juices, right? They're probably full of air, especially since they're always farting out of their face. So they probably just like float along the river. So if we made it, God, that would be the funniest damn thing ever. If like you're running along as Bitey and you like scare a whole bunch of fat sacks and they jump in the river and float away while they're like thrashing around like ah. That would be really cool. Alright, so I think we got a plan, and I'm going to take a short break here, a couple minutes, and I'll be right back. Alright. Well then, I think we've got our plan in place. For what we need to actually make here. Yeah, we got our plan. It looks like this. Alright, what do we got going on here? I think we've answered our questions. Alright, so we've got our water blueprint, we've got our water material. So let's get started on God, it's hard to figure out what the hell to do. Like, was it the scariest thing is a blank canvas? Well, that's definitely true here. Alright, so what are we gonna need? We're gonna need a function for like create height map, or update height map. We'll need another function. It's gonna be like update flow field. We're gonna need like construct static flow field. This shouldn't be update height map, it should be construct static height map. We may want to write some of this in C++, we'll see. Let's see, we're going to want a update ripple map, and we're going to want, let's just have update obstacle map. So different variables, we're going to want our water material, we're going to want our water material instance, so this is going to be a material reference, this is going to be a material instance dynamic. This is the material we use for the water. I don't want static mesh actor. I think I just want an actor. Yeah, so we have our we'll need a static mesh component. And we'll want that plane.